Welcome S5 students. Today we are going to discuss about gradient of some theorem of gradient of scalar point functions. If theorem if del phi del psi are del phi and del psi are two scalar point function, and if del phi, I am sorry, here phi and psi are the scalar point function. If del phi del psi exist in a given region R, therefore then del phi by psi is equal to psi del phi minus phi del psi upon psi square. That is, gradient of phi upon psi is equal to psi gradient of phi minus phi gradient of psi upon psi square. Proof: gradient of phi upon psi is equal to del phi upon psi is equal to I double double x double double x plus j double double y plus k double double z I vector double double x j vector double double y plus k vector double double z. Phi upon psi is equal to I vector double double x phi upon psi plus j vector double double y phi upon psi plus k vector double double z phi upon psi is equal to I, using differentiation of u upon v method, here phi upon psi, therefore psi double phi by double x minus phi double psi by double x upon psi square plus j vector psi double phi by double x minus phi double psi by double x upon psi square plus k vector double psi double phi by double x minus phi double psi by double x upon psi square is equal to, here psi, here psi, here psi, psi is common, I psi is common in bracket I dou phi by dou x plus j vector dou phi by dou y plus k vector dou phi by dou z upon psi square minus phi is common to all I dou psi by dou x plus j vector dou psi by dou y plus k vector dou psi by dou z upon psi square is equal to, we know that I dou phi by dou x plus j vector dou phi by dou y plus k vector dou phi by dou z and I vector dou psi by dou x plus j vector dou psi by dou y plus k vector dou psi by dou z. Here psi, this is del phi minus phi, this is del psi upon psi square is equal to gradient of phi upon psi is equal to psi gradient of phi minus phi gradient of psi upon psi square. Next, some examples. Example, if r vector is equal to xi plus yj plus zk vector, modulus of magnitude of r vector is equal to r, then prove that del phi r is equal to phi dash r delta r. Second, del r is the unit vector. Del phi is the unit vector. Third one, del log of r is equal to r vector upon r square. Solution, first del phi r is equal to I double x plus j vector double y plus k vector double z phi r is equal to I vector double x phi r plus j vector double y phi r plus k double z differentiation of phi r is equal to I vector derivative of phi r is phi dash r with respect to x, and derivative of r is del r by del x plus j vector phi dash r del r by del y plus k vector phi dash r del r by del z. Phi dash r is common. I del r by del x plus j vector del r by del y plus k vector del r vector by del z del r by del z is equal to phi dash r into delta r. Del phi r is equal to phi dash r delta r. Second, to show that del r is the unit vector, r that is equal to magnitude of r vector is equal to under root of x square plus y square plus z square. Therefore, del r by del x, differentiate this with respect to x, 1 upon 2 under root of x square plus y square plus z square, and with respect to x, y square and z square is constant, derivative of constant is 0 here, derivative of x square is twice x, is equal to 2 to get cancelled, x upon under root of x square plus y square plus z square. Similarly, del r by del y is equal to y upon under root of x square plus y square plus z square, and del r by del z z upon under root of x square plus y square plus z square. Therefore, del r is equal to I del r by del x plus j del r by del y plus k del r by del z is equal to, denominator is same, therefore xi plus yj plus zk upon under root of x square plus y square plus z square is equal to, this is r vector and this is magnitude of r, that is r, magnitude of r vector, that is r vector upon r, that is the unit vector r cube. Next one, we let phi r is equal to log r source. Therefore, phi dash r is equal to 1 upon r. Therefore we know that from result first, del phi r is equal to phi dash r into delta r is equal to phi dash r is 1 upon r, and from result 2, delta r is the unit vector, that is r vector upon r, that is equal to r vector upon r square. Next example, if r vector is equal to xi vector plus yj vector plus zk vector and a vector b vector are constant vectors, so that करो ना 5 मिनट पुढे थांब, माझं लेक्चर चालू आहे. हाँ, so that del r vector dot a vector is equal to a vector del r vector a vector b vector is equal to a vector dot cross b vector. First, a vector is equal to a1 I vector plus a2 j vector a3 k vector, that is constant vector, and r vector is equal to xi vector plus yj vector plus zk vector. Therefore dot product of r vector dot a vector is equal to xi vector plus yj vector zk vector dot a1i plus a2j plus a3k is equal to a1x plus a2y plus a3j. It is dot product of r vector and a vector. Therefore del r vector dot a vector is equal to I double double x plus j vector double double y plus k vector double double z r vector dot a vector, that is a1x plus a2y plus a3z. And with respect to x, a2y, a3z is constant, therefore the rate of constant is 0. Only the derivative of a1x is a1 plus, with respect to y, only the derivative of a2y is a2j vector plus a1x and a3j are constant with respect to y, derivative of constant is 0. K vector double double z, with respect to z, a1x, a2y are constant, derivative of constant is 0, derivative of a3z is a3, that is a vector. del r vector dot a vector. Second, a vector and b vector are constant vector. Constant vectors. Therefore, cross product of constant vector is again constant vector. Is constant vector. Therefore, del r vector dot a vector cross b vector is equal to a vector cross b vector, since by first result del r vector dot constant vector is equal to constant vector. Therefore, del r vector dot a cross b, that is constant vector, is equal to constant vector a vector cross b vector. That is del of scalar triple product a vector cross b vector. Next example. Prove that del r raised to n is equal to n r raised to n minus 2, where r vector is equal to xi plus yj plus zk. Solution: del here r raised to n is scalar quantity, therefore phi r is equal to r raised to n. Phi dash r is equal to r raised to n times r raised to n minus 1 del r. Is equal to n times r raised to n minus 1. Since del r is the unit vector, r vector by r by previous result, therefore del r is r vector upon r is equal to n times r raised to n minus 2 by law of indices into r vector. Okay, we stop here.